Jose Luis does this like, hello. But Michael Wickerson here with Sergi. We're going to take a look at Cocoon, a plugin you can bring in off of bespoke geometry. You got to go to that website. It's got some nice examples. And this is kind of what's happening with mesh constructions before I'd say the subdivision kicked in. And I don't know how popular it is, but let's take a look at those 6 nodes and what they do, and I'll try and put them all to use. So we will immediately, when you go to one of my scripts, and I'm kind of teaching Sergi this because we're going to learn Grasshopper next week, you right-click on it and you ungroup. What you do that for is then you can get in and you can actually pick these. They're easier to select, left and right select, because if you're in a group, then it gets tricky to try and select exactly what you want. What have I generated here? Let's take a look. Obviously, I've generated, and for plugins, which I don't believe Sergi has on Windows yet, you're going to want the bifocals tool, which allows you to look at icons, and I'll show you how to download that to your library, because everything says what it is, and you start memorizing the icons. So what I've done is I've grabbed a positive and negative in a domain, so just think of that as an X value, and constructing a domain in the Y, and then constructing a domain in the Z. So what I end up making is a box, and that's exactly what we made. But I have control over my box. Does that make sense? It's a domain that I can go in Z, X, and Y. It's pretty simple geometry, but that's why I teach the maths right off the bat. I'm going to populate that, and you can see how it's populated with 8 points. And I'm going to use that data to drive something farther down. I also want to seed, which randomly will take those points and seed them. It's a randomness, but nothing in computers is random, because I can always go back to 26, and it's the exact ones the computer knows. So we're just going to have 8 points. Now with 8 points, what can you do with 8 points? Well, I'm going to treat it as a point charge because that's one of the mesh Cocoon nodes. Right in here, the point charge is the one down near the bottom. So I put it into application. It's going to need a radius. So I basically said, let's just have a random radius, which will come out because of these numbers that are being driven by here. So the construct domain radius would be between 2 and 16. And that domain range, we can take a look at the number from 2 to 16. The number being generated is 8 because that's what I hard coded in. So that's where I drove that. And the randomness is anything between that. So there's where you get a little bit of randomness for radius, which is why you end up with a point charge, which is not a geometry. It is exactly what it is. It's a matching cube, and it's the plugin running. But since it's operating, it's not telling you what to do with it. I have to do something with the charge. So I need the plugin Cocoon, because I needed to generate a charge. And I decided out of all of these plugins that I could have done it in these other ways, curve charge, but the point charge will be the one I use in this example. It then needs an ISO value, which would usually tell you what it needs to run from. And I've set it between 0 and 1, and many plugins have a point charge that kind of operates in between, but you can see how that's going to, it gives it kind of a, the reason I like the point charges is if you go back into your maths, actually back into your vectors, you'll see the first section is a field, and actually getting charges onto a field. And I didn't do any examples of that because those are like a micro plugin in the ribbon nodes, but here's a really nice one. Execute is just a Boolean. If you hover over here, you'll see it tells you over here there's a little Boolean symbol. That's why you want to memorize your parameters and know what these things are. It tells you what it needs. And of course you can set it to true and false. If I set it to false, nothing's going to appear. If I set it to true, it's going to run. So it's a pretty simple tool. I showed you how the Cocoon node works. Component Cocoon works with a point charge. And that's it. It's up and running. It takes 253 milliseconds to run that script. And then if you like what you have, you also have this output, which is a data, which doesn't tell me anything specific, but I guess you can use it farther down the line. But these are like micro plugins as to what you can do. And the mesh, you can always bake it. And when you bake it, it's like you put it in a kiln and you fire it. If you have to group it, you can, but now it's in Rhino. And you can leave Grasshopper. So think about trying to make that form in Rhino and control it and have a perfect closed mesh. We've done it by the point charge. So we're going to delete that and go back to here. So that one's running fine. Let's take that whole item and see if I use the other nodes. So this is like, you don't have to do anything. Everything's provided for you here. You simply open it up and start creating geometries, and you play with it until it doesn't work. So down here, I can take all these ones, and I think I'll take them all, and they're all running. But let's do the same thing. And take a look at ones and see what we're actually doing. So again, I made a box, did it the exact same way. And honestly, I boxed it up here because that's the exact same script that was in there. So you don't have to think about it. It's like object-oriented programming of sorts. That's packaged and it's working. I did generate this and I generated that. Now it's very interesting to think how I pulled that out of these forms, because those are intersection surfaces on some type of solids. So let's see what happens. And these are not my scripts. These are from watching tutorials or videos. Debrep is a wonderful tool of taking a box and getting its faces, edges, and vertices. And I only need a list item because how many faces are there? There's 6. So I can roll through my selection of my face and choose whichever face I want. So I think we're happy at the 5. And then I'm going to use a brep wire, which I don't think comes out of. If you ever want to know where a node comes from, hold down Control-Alt and tap the node, and these little red arrows come up and tell you exactly where it is. So you can find it. You see that's in Surfaces, under Analysis, and brep wireframe is in there. So there's my wireframe. I'm using that data to garner these curves, and just to make sure they're all together, I join them. I use the node join. Now down here, I'm also saying, let's take those faces and find another one at another number. So this one I was choosing that one, this one I was choosing that one. So those things, basically the same scripts running twice. So we follow it farther downstream. I'm going to populate that 2D geometry up here. You can hold shift to see where it came from, and I populated it. And it has its own seed. So if I didn't like it, I could change it. So you have total control manipulating. And I did the exact same thing down here and here. So I can populate that and do a random seed. So I've got points on breps that are generated. So you see why I'm teaching you Rhino the way it is. Now I'm going to draw lines between them. That's pretty easy. So you've got a 3-dimensional line structure. And then Bezier curve is a way of making a curve. But you also can make it from Nernst curve, from interpolated curves, whatever you want. But it demands different things. Tangents. And I've done it through a lofted form here. I have to wonder where that Bezier curve is. It turned those into these nice Bezier curves as opposed to what they were before. And I just thought the geometry was nicer to look at. Probably came from a tutorial, and I didn't think to use that because I don't use Bezier curve that much. But if you go into curves, you'll see you had all these wonderful choices and splines that you could have chose from. And they just chose the first one, Bezier span, Bezier, I don't know. It's in there somewhere, Nernst curve. Anyway, I'm not going to dwell on it. I'm going to lose my geometry. I'm now going to go in and see what else I had. I went back here and I said, let's take that whole box and let's grab some points in there. So additional points that are in there. Now I'm driving the data up because of these Bezier curves, because that's all that's continuing. Follow the lines, this line and this line. So you kind of package that all the way before, and now you're set into here. What am I going to do with these points? And what am I going to do with these curves? Well, those curves are going to become the curve charge, which doesn't do anything geometrically, but he does it number-wise, and we know we can feed those charges into this geometry, and that's how we end up producing that one. So if we leave, we know exactly how those ones were built, which is a pretty interesting point charge. And then you end up with a mesh. Well, what I did up here was I randomly created a point charge over here, which was taking the data and putting it in, so I generated a completely different geometry. One's driven by a curve charge, one's driven by a point charge. And that's how somebody wrote. And when you get good at these and you figure out how to make inputs and outputs, you'll realize that this is extremely similar to coming in, grabbing a Python node and saying, well, this thing kind of works exactly like this. I sure could make this if I typed in here and said this was charges, right? But you have to understand the script. And if I went in here and said, oh, it's got a few more points, I have to add them. Sorry, like this. You can see how you start to get your head around, oh, my head's in the way. You can start to see how you build the script, and you have its outputs that you can title. They're written within the script, and the script's written off to here. So you actually write exactly what the Python charge does. That's probably written in C#, but it might be written in Python. I'm not sure. We're going to go there in the last chapter of what we're doing. But right now you can see how that geometry is being driven by those point charges in this one. What did I do to this point charge was I grabbed that mesh box, and I said, what if we split the mesh because of these geometries? Literally, what that does is it takes the mesh and splits the mesh from it. And so it ends up generating list items of all the sections that are split out. I don't know how many there are, but the results are there's 4. Just because. Now that result will change if I change my shapes. But basically, if there's 4, I can number slide 0.3. And I can say, okay, that's my intersection on that side. But what happens when I start to drop it through here? You start to see all the sections of what can be split. And what I did was run into here and say, okay, if those are all the instances of it, I can just take a look at each section. So if you start thinking color coding a building, you're going back to that mesh coloring, you'd have it. So it's not hard to think of the interior, but it's really allowing yourself the creativity to find these things. Whenever I add a new element like that, I'll just go here and I'll say add to group, and that'll be added, and then I'll save my file and I'll update it on my GitHub. So as I save that, then I can take this whole new form. And that's it. Basically understanding Cocoon You grab the whole thing again. When you've played with each of the nodes, it's still not showing red. And you group it, and then I usually make it a baby blue because that's the color that tells me I was looking at it. And everybody else can grab their colors they like. Yours will be red or gold. I know that because that's what you liked in that one piece you were making, but maybe not. The thing up here, which is key, is what I put at the beginning of all plugins. Plugins can be used simply and can be delved into on a more advanced level. So you can look at the plugin like Lunchbox, and you can immediately start building geometries out of this, but you can also go in and jump into machine learning and grab any one of the machine learning techniques. Like linear regression is going to take a bunch of points, and it's going to show you where that estimated thing is. And I started with that plugin. But plugins, that's not what I'm trying to say. What I'm trying to say is they can be easy or hard. The key is to understand how they were constructed from the vanilla nodes, most of them being generated, at least in my opinion, by the maths, the sets, and the vectors. And then when you can do that off the ribbon nodes for Rhino 7, only then will you be able to start programming and compiling your own plugins that have yet to be created for parametric and computational design, which is the whole point of the course. So I don't know what came up here, some weird scan thing, risks. That's about it. So you can always just zoom extends all. This is a nice little toy that'll do that as well. And you can shrink that back and you can grab the geometry you're looking at. Not too exciting there. And over here you can select all the geometry, just what's been highlighted. That's about it. I'm going to tuck that back up there. That was a crazy video, but I'm starting to involve Sergi, and Sergi's going to start getting more vocal in time, maybe with questions. I like this. It's a little long, but it does just zoom and extend everything. The only thing I still want to organize is just keeping my scripts neat and organized. Otherwise, things go to shit really quick. Here's a little tidbit. Oh, I did use a bad word finally. You can go here for wire displays, which are nice. Say you wanted that wire display and it was getting really nasty to look at. Just a little technique. I'm just throwing this out because you're going to begin Grasshopper. This not wire display, you can go in and grab hidden, and then there's a little. So when you collect it, you'll see where it's going. But when you don't get mixed up by these wires. So you start to clean up, obviously, how things look. So you start to follow. You see your script written out. So wire displays, hidden, and then any geometry you brought in, you probably want to internalize it. But you'll see my Grasshopper scripts don't start with any points or anything imported from Rhino. There's no 3DM file that's necessary to get the script up and running. And that's the same with all the scripts I'm using. So what I'm going to do now is I'm going to file save that, and then I'm going to go in and I'm going to do file open, and we are going to jump into we're going to jump into Voronoi, which is an overused tool that way too many people do, and you get in a lot of, it actually has a warning when you start to use it to say, don't use this, because everybody uses it. And you'll see it when you do it for the first time. So here's the Voronoi example, and I used a image sampler, which came from Daniel. But as soon as I see that, I know it's Daniel Christes. But actually, it's David Kopetti's. Oh, I stole it from David. So I'll give him credit. I enable that, and you can see what's happening. It's a top view image sampler of the Voronoi pattern. And you can see there's actually in there, it's hard to see on this view, but if I go to top view, you can see that that's actually kind of me sitting there like that. It's being driven by that data. And depending on what I end up doing with it, like this data, I've chosen to fudge it out. I'll get into that on the next one. And I'm actually using some logic of greater than or less than to allow this to have a little bit of interplay as to what's actually coming up. So you're driving data from an image, but you're choosing how much finesse you want from it. And we'll get there for the next one. This is a David Kopetti, so I need to give credit, and it requires Lunchbox to get it up and running. And here are some great examples, so to link to his site. All right, I better end it. It's